Hello everyone. Today we are going to see a new concept from EduTech AGR, Gauss's theorem. I am going to explain you the statement and its proof. A very important theorem, exam point of view as well. Let us go with the statement first. The statement says that the total normal electric induction, that is also called in short as T dot N dot E dot I over any closed surface is equal to algebraic sum of the charges enclosed by that surface over any closed surface with any number of electric charges is situated inside it is equal to the algebraic sum of charges. So this was the statement. As I explained, as I told you, and the algebraic part, the mathematical part of the statement is T dot N dot E I N dot E dot I, that is equal to algebraic sum of the total charges. अगर एक enclosed sphere है या एक enclosed surface है जिसके अंदर अगर n charges है तो उन सब का total is always equal to T dot N dot E dot I, total normal electric induction. चलो, let us go to the proof of the Gauss's theorem. Consider an enclosed surface, irregular enclosed surface with a point O inside it. I'm considering one. Let me complete the diagram first. As you can see, there is a diagram inside it. So from O I'm making the lines which are moving towards a small area ds, and it has made a solid angle d omega. This is an electric intensity produced at area ds. So the point O has charge plus q. This is angle d omega. This is area ds, small area ds, very small area ds, and this is an angle theta made by E electric intensity with the perpendicular. So the perpendicular vector to the area will be E cos theta, and the distance from the center from point O to point P, that is an area ds, is r. So I'm writing the same part which is required in the derivation. See class, बच्चों, ये जो derivation है, this is completely exam point of view, point to point derivation. So please go through it again and again, try to write it. This is just an option for the revision, or maybe to learn, as you are good teachers will teach you this derivation in class. Then once while sitting in the hall, maybe looking in your laptop or your mobile, you can revise it anywhere at any place. So the basic idea of this derivations concepts is not to replace the teachers, but to explain you at your places, wherever it is, just for a revision maybe. Okay, so this is again all the same things which I've explained you. Consider an irregular surface of any shape which is enclosed number of positive charges. To prove the Gauss's theorem, imagine a small charge plus q present at point O inside closed surface. Imagine an infinitely small area ds of a given irregular closed surface. Please excuse me for my handwriting. It's not a bit good, but the ideas are just to make it easy. So the magnitude of the electrical field which is coming out at ds, the magnitude of electric field intensity at point P on ds due to charge plus q at point O is E is equal to 1 upon 4 pi epsilon. Epsilon is also called as permittivity. You can see now. Now you'll see the formula. at point O. So the formula is E is equal to 1 upon 4 pi epsilon permittivity. Sorry, I've written epsilon not. It's epsilon. I've taken it general for any medium it is. If it is for air or vacuum, you can write that as epsilon naught, as we all know. This is the magnitude of electric intensity due to plus Q at ds. See, सबसे पहले the idea of the derivation हमेशा याद रखने का कि पहले अपन पॉइंट Q के वजह से एक छोटे एरिया पे इलेक्ट्रिक इंटेंसिटी कितना आ रहा है वो देखेंगे, फिर अभी अपन टोटल एरिया का देखेंगे. तो सबसे पहले I have shown you the magnitude, now I am showing you the direction. As we all know, let theta be the angle subtended by a normal drawn to, as I have shown you in the diagram, drawn to area ds with direction E. So the normal electric induction, that is only the electric induction due to that plus Q over area ds due to the small, that is also called as n dot E dot I, will be equal to epsilon E cos theta ts. It's been, this all concepts has been explained to you all before. Again I have done a mistake. एप्सिलॉन के जगह पे एप्सिलॉन नॉट लिखता हूँ, क्योंकि क्या होता है बहुत बार प्रॉब्लम्स में एप्सिलॉन नॉट आता है, इसलिए बहुत बार बाय मिस्टेकली हो जाता है, बट इट्स ओके. एक्सक्यूज मी. So now in this derivation, see you can see d theta cos theta by r square को मैंने एक साइड पे ले लिया, which is a solid angle d omega. So this was normal electric induction over area ds ड्यू टू प्लस क्यू. तो टोटल निकालने का कैसे, ये तो छोटे एरिया के लिए प्लस क्यू के वजह से था. अभी टोटल नॉर्मल इलेक्ट्रिक इंडक्शन कैसे निकालना है, तो टोटल नॉर्मल इलेक्ट्रिक इंडक्शन over the closed surface, the total surface, since the surface is continuous, we can take it as Tne I is equal to integration of q upon 2 pi of d omega. So q upon 4 pi को कॉमन ले लिया, इंटीग्रेट किया डी ओमेगा को, डी ओमेगा का इंटीग्रेशन विल बी द टोटल एंगल 3D एंगल विल बिकम स्फीयर विच इज 4 पाई. तो 4 पाई कैंसिल, तो टोटल नॉर्मल इलेक्ट्रिक इंडक्शन ड्यू टू प्लस क्यू एट ओ विल बी ओनली क्यू. सो एक पॉइंट था प्लस क्यू, उसका TNEI पूरे सरफेस के लिए प्लस क्यू हो गया. तो सिमिलरली अगर एक के जगह पे दो होता, जैसे Q के जगह पे Q1 होता, Q2 होता, Q3 होता, Q4 होता, तो Q1 के वजह से Q1 होता, Q2 के वजह से Q2 होता, Q3 के वजह से Q3 होता, एंड सिमिलरली Qn के वजह से होता. तो दैट इज व्हाट वी आर गोइंग टू एक्सप्लेन एट द लास्ट पार्ट ऑफ दिस डेरिवेशन. इसके लास्ट पार्ट में भी मैं वही एक्सप्लेन करने वाला हूँ, एंड वी आर गोइंग टू राइट. सो एज आई एम राइटिंग TNEI ड्यू टू चार्ज प्लस Q ओवर अ गिवन क्लोज्ड सरफेस इस प्लस Q1, एज आई सेड Q1 के वजह से प्लस Q1, सिमिलरली Q2 के वजह से प्लस Q2 होगा. इट इज द सेम लाइन, यू जस्ट हैव टू राइट इट. एक चीज ही 2-3 बार लिखना है, तो इट इज वेरी इजी टू रिमेंबर. सिमिलरली Q1 Q2 का है, वैसे Qn का है. तो एक एक चार्ज के वजह से अकॉर्डिंगली Q1 के वजह से Q1 आया, TNE आया, Q2 की वजह से Q2 आया, Qn की वजह से Q1 आया. तो टोटल बाय सुपरपोजिशन प्रिंसिपल अगर सभी एक साथ अंदर है, तो सिंपली अगर सबका एक एक करके Q1 Q2 Qn आ रहा है, तो सब जन जब एक साथ है तो सबका सिंपल एडिशन होगा. दैट इज मीन TNEI ड्यू टू ऑल द चार्जेस enclosed by the given closed surface is TNEI is equal to Q1 plus Q2 plus Q3 plus dot Qn, which will be equal to summation of Q, which will be equal to total charge enclosed inside and hence the Gaussian theorem proves. I hope so my derivation, my proof is clear. So I hope to see you again. Bye. Infiniti EduTech AGR. See ya.